All right, here is the key for investigation 4.2, Newton's second law. The first part, number one, you should have identified the independent variable as mass. If you left this blank, then you need to type in mass in red or a color of your choosing so that I know you've made that correction. If you already have mass as the independent variable, then you do not have to write or type anything. Our dependent variable was time, so please make those corrections. If you had both of these typed in, then in parentheses, you can simply put no corrections. And then I will know, and again, sorry, this should be in a different color. And then I will know that you did not have any corrections. You had it right. You scroll down. This is what your data table should look like. You have the title, the effect of mass on time. So even though your experiment, we had our car, even though we did not measure the mass of the washers and the car, what I did explain was that mass was the independent variable, but we're using number of washers as the unit. And a lot of you did ask me, and we discussed this. We have no washers, or you could have 0 washers. Again, your independent variable goes here in the left column. So no washers, 4 and 8. You don't have to have the words washer. You could just simply have 0, 4, and 8. Up here, a lot of you left this blank, but I don't know what these trials mean if you leave this blank. So here we have time to travel, which was 70 centimeters. I would actually put this here. So time to actually, I'm going to change that again. Time to travel was 70 centimeters. So we timed a specific distance. The distance was kept constant in this investigation, but we measured the time. We did not measure distance. We measured the time it took from start to finish, which was 70 centimeters. And then your trials, here's the time. And because we have the S up here for seconds, you don't need it here. But if you have it in each box, that's completely fine. But it looks a lot cleaner when you just keep it up there in the headings. And then finally is your dependent variable in the right column, which was your average time, which means you had to add each one up, each trial up, divide by 5 to gain your average, which was 1.46, 2.35, and then 3.45, which makes sense because as we increase the mass of the car, it took a longer time for the car to travel 70 centimeters. We used a line graph, very simply done. Down here is your independent variable, mass, parentheses, number of washers. On your y-axis, your dependent variable was time, unit is seconds. Graph has a simple title of mass versus time. And then you'll notice you have a slope that is inclining. Now, if you have the incorrect graph or you are missing labels or a title, you need to redo the graph. You are not just going to put a line through it and write the title, I want a new graph. So anything that's wrong here, please keep this here and then add your corrected graph. Please use a different color so it stands out. And then you will insert it here. And watch your spacing. Now for our analysis questions, we changed the mass of the car and kept the force the same. How did the speed of the car change? In your explanation, include Newton's laws. So I made sure to put the second law here so that it helped you with your answer. So for number one, when mass of the car increased, the speed of the car decreased. That's pretty evident when we look at our data and when we look at our graph. More mass means more time it'll take to get from point A to point B. Now, what we also kept consistent or constant was the force applied. So if we think of two cars, same exact car, same size, right? But one car is filled with things from Target and the other car is just with one person in it. The car with all the Target supplies in it is going to have more mass. Can they travel at the same speed? Yes, they can. But the car with more mass is going to need more force applied in order for it to travel at the same speed as the car with less mass. So if we wanted our little car to travel at in the same time every time, we would have to increase force. Now, some of you also, going back here, put acceleration or you put speed. You did not calculate acceleration, nor did you calculate speed. That is why it's just mass first time. You would have to have done a calculation here before you ever graphed, or before that would ever have been your independent and your dependent variables. And then this is the second law states that the acceleration of an object is dependent upon two variables, mass and net force. In this experiment, the force of gravity and the washer bundles was greater than the mass of the car, which allowed the car to move over the 70 centimeter distance. So you are more than welcome to copy and paste this or put this in your own words. Do not delete your original answer. Please add to it. And I like that some of you will, like say you missed the word decreased, you'll add that in and you'll indicate that by putting it in a different color. That's a very good strategy, those of you that do that. For number two, if we kept the mass of the car the same, how would we make the car go faster? So I literally just talked about that. I kind of went ahead of myself. So if the mass of the car stays constant or stays the same, but the net force acting on the car being increased. So that means the car's speed will continue to increase as the net force is increased, just like when we drive a car. So if we keep the mass the same and we want the car to go faster, we just have to increase the amount of force or the amount of net force. This is what you need right there. If we keep the mass of the car the same, in order to increase the car speed, we must increase its net force. I'm going to get rid of this. And go ahead and copy and paste this as well. This way you have that information for later.